Andy Furnell from Zen Internet, here to talk about a variety of things to do with how we've been dealing with and increasingly preparing for increased growth of Ultrafast and other very, very high-speed services on our network. As Keith said, we're a very local ISP to this neck of the woods. We're based in Rochdale, about 15, 20 miles up the road. Has everyone here heard of Zen? Can I slip? Yeah? Good. This is really good. So I can skip this slide. I've got a lot of material and it's going to be quite rushed. I've tried to cover a number of different areas. I'd love to come back at a later point and go into some more detail about some of these things. So do come and grab me afterwards at lunch in the break this evening if you want to know anything more. But yeah, key facts. We're privately owned. We've been going since '95. As a consequence, as you'll see, we've got an enormous amount of legacy that we've been carrying for a lot of time. So part of this is about actually how do we evolve our network, drop some of that legacy to allow us to move forward. Key points here, we've started doing LLU, putting our equipment out in BT exchanges in about 2013. And this presentation, this sponsorship is actually being provided by our Wholesale division. We launched a range of Wholesale products. We started development in about 2012. We launched slightly bigger in 2015. And we've got a variety of different Wholesale DSL products that there's a number of people outside who'd be more than happy to talk to you about. So I'm going to start off talking a little bit about capacity management. And I thought, there's a lot of people who work for ISPs here. Some of this people will know, some of it is some new things that we think we're doing, so some alternative takes on things. But if you look at network capacity, what customers tend to expect is if you compare a network to a road, they've got their own road, they can use it anytime they want, and there's never going to be anyone else on it. And we try and balance that against the desires of our finance director, who wants to provide just enough, not too much, not too little, just enough to keep things moving. Our engineering team know that actually driving on roads is never the fastest way to get somewhere, and the best way to get somewhere is in fact to build trains. But actually, and I struggled to find a picture for this, actually capacity management is this sort of delicate balance of trying to balance cost and efficiency and time to market and the quality of the services that you provide. So I want to talk a little bit about how we do that delicate balance in Zen. It's something that our customers quite often ask us. I see a few of our customers around here, so hopefully this will address some questions you've had and open the lift the hood a little bit on what it's like to be involved in the infrastructure that we run. So there's kind of three parts to it, and I thought I'd throw up some hopefully interesting numbers here. The first part to managing capacity for us is about knowing who your users are, where they're connected. And these are some traffic graphs from 3 different points in our network. At the top, we've got, this is the traffic that an individual subscriber generates. This is one of our business users. That traffic happens predominantly during daytime hours, during working hours, Monday to Friday. But actually what we see is that it's very, very peaky. So the ratio between the peak traffic that subscriber generates and the average traffic that subscriber generates is about 7.5 to 1 in today's network. That's an average across our entire user base. So while the average consumption on a per subscriber basis might be relatively low, when we provide capacity, we need to make sure that we're providing enough capacity so that they can burst to use those peaks when they need to. It's kind of intuitive, but the closer you get to the core of the network, as in the greater aggregation you've got of subscribers, the greater density you've got of subscribers, the more of a smoothing, of a flattening effect that has. You get great statistical multiplexing as you head towards the core. A lot of customers, their peaks balance out other peaks, their troughs balance out other people's peaks. So the takeaway here is that in real terms, what we're seeing is as you go each step into the network, so from an individual customer to one of our local exchanges aggregating 50, 100, 200, a few hundred customers, those peaks start to flatten out, and in fact the ratio of the peak to the average traffic for that part of the network really halves, and it halves again once you get into the core again. So the nature of the capacity that you need to provide and the relationship to the usage, the underlying and average usage profile of that part of the network really changes depending on how many users you've got and which particular part of the network you're looking at. This is, so we now know where the customers are. We need to do something with that. So this is, I think, not a new technique that I've got described here. This is something that you could go to Cisco or OpNet or a variety of people, give them tens or hundreds of thousands of pounds for a piece of software where you plug your network in, you tell it your traffic matrix, and what pops out the other end is a set of capacity planning coefficients or dimensioning guidelines for links in your network. We don't have tens or hundreds of thousands of pounds to spend on capacity planning tools. So what we did, we need to model our network anyway for training purposes, for documentation purposes. It exists in, here it is in GNS3. We're modeling our new Huawei network in their equivalent. So we have a model of the network that exists today. It represents all of the IGP metrics and the BGP costs and the HA setups and the FRR setups that we have in the live network. So pretty much all we did is we attached a virtual PC to each node in the network. And then we started breaking stuff and wrote some Perl scripts that systematically go around and fail every single link, every single node, every single pop in the network that exists. And you watch what happens. And the way, in this case, that we watch what happens is we shut some links down. We run a bunch of trace routes from every single point in the network, see what the traffic paths are under that failure, and then create another type of failure and do the same. Repeat the whole exercise over and over again, programmatically, hundreds of times. And what you get is, step 3, a very, very big Excel spreadsheet that has a number of failures. For each failure, where does the traffic between each two endpoints in the network go? And then on top of that, we start overlaying the data that we saw in the previous slide. So, what is the traffic that we expect to see between two endpoints in the network? What is the worst case traffic load on every link in the network for that traffic load? And what comes out the back of it is a set of planning coefficients where we can say, for a given traffic load in the network, be it 10 gigs, 100 gigs, whatever, we multiply that number by the traffic coefficient value, and that tells us how big that particular link in the network needs to be, so that we've always got enough capacity to handle the failures that we've modeled. I'd really hoped that we'd have this ready by the time I came to speak to you today. Please do keep checking back. We've got an engineering blog that's starting to pick up some pace, and we'll be posting some details on exactly how we do this, some how-tos, some code snippets over the next few weeks and months, if that's something that's of interest to you. So we know now who our users are, what kind of traffic they generate, what kind of load that traffic puts on different parts of the network. Now we need to figure out how much traffic we actually need to cater for in the future. There's a very, I'm assuming a lot of people are familiar with Cisco's virtual visual network index report. It's a great view of how they think bandwidth's going to increase over time. And actually, in my experience and our experience, it does tend to be reasonably accurate. Cisco here are predicting 20% broadly compound growth per year over the next few years up to 2020. What we've seen in our network is actually a considerable amount more than that. And one of the things that's really driving that is the peaks of an ultrafast service of 2-5 gigabit services are much peakier than what we've seen before. So the average traffic is kind of growing at 20%, but the peak traffic is growing much faster than that. So what's that made up of for us? How do we actually figure out how much bandwidth do we need to provide at a different point in the network? It's a layup here. So we've got something that people are probably familiar with, peak average demand. So this is the average consumption per user during peak hours. And that's the baseline amount of traffic that we need to carry. And then on top of that, we've got, everyone's experienced some lags or some equal cost multipath that isn't quite as equal as you thought it was going to be. One link gets hammered and two of them do nothing. So there's always a bit of inefficiency in your infrastructure you've got to cater for. And always that one box that the vendor says, yeah, of course it does 10 gig line rate, but you put it in the lab and it turns out that it does 10 gig line rate except on Tuesdays when the sun's shining and it's raining in Rochdale or something. There's always these weird things that come to bite you. A +1 for resiliency. We have a variety of different resilience models in our network. It can be doubling up. It can be, we've got 3 platforms. We had a 4th one. But we're actually starting to get a lot of traffic here. That peak average demand actually drives a significant amount more capacity than just the demand itself. This is what happens when Theresa May announces a snap general election on Tuesday morning. This is, people will be familiar with this stuff. It does happen all the time. Sometimes it's going to happen. There's Olympics and there's sporting events. Sometimes it just happens and you don't see it coming. So there's always an element of headroom that we need to provide. And actually, if we look at the network that we operate, what we're seeing is that the 1 megabit of demand down at the bottom actually drives about 4.5 megabits of capacity on average across different parts of the network for us just to be able to keep our heads above water. And then when you add Ultrafast into the mix, I said earlier that we've got this peak to mean ratio of about 7.5 to 1 for an 80/20 FTTC user. That's about what we see. For our FTTP users, what we see is that actually the peak average demand doesn't really change. We're still seeing between 500 to 1,500 kilobits a second average peak per user within our network. But actually, it's the peaks that really start to the peaks get peakier. The average doesn't really change. So all of a sudden, our 4.5 megabits turns into 7 megabits of demand. And for us, that's quite challenging. We're a relatively small provider. Our network generates sub 100 gigabits a second volumes of traffic at peak. And being able to handle those really peaky peaks is quite a challenge for us. So there's 2 things that we've been working on. First is, I said earlier, we've done some LOU in 2013. About 12 months ago, we started a program to go from 200 exchanges to 400. Now, people might think, well, you're going to save loads of money. Actually, the driver for us for doing LOU is a lot less about we're going to save loads of money and cost efficiencies and giving less money to wholesale. It's much more about the opportunities to improve the quality of experience that we give our customers. Cutting out that wholesale middleman for us is pretty important. Giving us direct access to the copper gives us much more room to differentiate the services that we provide and the services that we offer to our customers. And at the same time, and you might have read about this, we've done a few press releases on this now, we've decided to build an entirely new greenfield network in partnership with Huawei. And we'll talk a little bit about these 2. There's been a number of presentations on this over the years, and very good presentations, and I'm not going to reinvent the wheel on this. LOU is difficult and expensive to do. It takes a lot of time and it takes a lot of effort. Here are, for us, this is broadly what an LOU exchange looks like for us. That's about £15,000 of investment just to put infrastructure in the ground, just before we connect any customers up. And actually, over half of that is going on a rack and some power for it. The other thing to call out, GEO cable links. We have a full mesh of connectivity in all of the LOU exchanges that we're in at the moment. We connect into all of the FTTC current generation cable links. about 2.5 cable links per exchange. What we're seeing with Ultrafast now is, unfortunately, we're going to have to go out and buy a whole load of new cable links, particularly with looking at GFast trials at the moment. That's another dozen cable links just so we can connect to the GFast network. So this is, it's not something that you get into lightly. This is an investment that really you have to be willing to keep it going, both from an operational cost, but also from it's a continued investment to maintain this and keep current. So what it's looked like for us, it's a £15,000 investment per exchange. We've had about 6 full-time engineers on this for 11 months, and some stats about what our experience has actually been. You know, it's 7 months optimistically from start to finish to get an exchange put in the ground for us. Huge amount of effort. And we built a new network, and I'm going to gloss a lot of this because I suspect I'm going to run out of time fairly soon. It's a new network built in collaboration with Huawei. We're doing something that I've tried probably for the last 15 years to do and in previous companies and never quite been able to do it before. We're pushing MPLS right down into the exchange. What that means is a much, much simpler network for us to operate. We accept the pain of pushing MPLS, a little bit more complexity into those devices, a little bit more cost into those devices, but it really simplifies the services that we're offering. Gone are the days of stitching VLANs together and trying to attach them into services. The average service on our network, I think, is made up of 5 different components. With MPLS, it's 1. It's a pseudo wire that attaches into another. Into a higher order service, and that's it. The other thing that we've done is, because of the unique nature of Huawei's very diverse product portfolio, we've been able to build something that the enterprise guys have been doing for a while. You know, a horizontally scaled leaf spine core architecture is very much. It allows us to scale according to future demand that we can't predict. So, you know, when the next technology comes out, and Neil talking about peaks of 10 gigs for 5G access, a little bit scary. We can buy the technology at that point in time that's relevant to what's available. We're not forced into line card upgrades for boxes that are now 5 years old. You can't get the line cards for them anymore, or you're not on the current generation. This, historically, I'd call it numbers to bamboozle and impress. This is what's involved in building a network. We have 110,000 circuits attached to the network, but actually the amount of capacity, the number of interconnects that we need to provide just to provide a service to anyone is huge. I was going to talk a little bit about some observations we made about the procurement exercise that we went through to build a new network and the kind of exercises that our customers go through when they're buying wholesale services from us. I'm going to skip what we observed and go straight into the fun stuff, because ultimately I've got sales guys outside who want me to make a message that supports our wholesale ambitions here. So there's really 3 key messages that I wanted to get home here. First is, we're a small, friendly provider from Rochdale. The people who are sat sort of 5 from the back on the right-hand side here, I've got 3 of our engineering team here. These are the guys who design the network. These are the guys who build the network. When you sign up as a wholesale customer of Zen, these are the guys who will be helping you through the process of getting you on board, helping you through the process of building your network to integrate with ours. And now I'm properly getting done for time. So, only other point, we are building a wholesale test facility that later in the year for new wholesale customers will be able to come in, do integration and interoperation testing with their CPE, with your network in a lab environment, no needing to migrate your live customer services over, we think is a really good thing. And just to finish, the most important point on the entire deck, we offer a variety of metered and unmetered, managed, layer 2, unmanaged, wholesale, ADSL, FTTT, GFast, FTTP offerings, and there's a number of people outside on the Zen stand who would be more than happy to talk to you about those and allow you to play Sega Rally to win an iPad, if that's what floats your boat. So sorry I overran, but thank you very much.
Thank you, Andy. Any questions? And you have a really cool game at your stand as well. So.
Exactly. From 1995, which was the start of Zen, so it all makes sense for us.
So go check out the game on their stand. Okay, thank you.
Wonderful. Thank you.